Hey there, folks. Welcome back to my thing where I am making a Tetris data extractor, where we extract the information from a Tetris screen as seen on the Nintendo. So let's get into it. Last time we moved from the emulator screenshot. We tried to move to the actual screenshot as seen on the Nintendo. It kind of worked. I should start this up here. If you'll recall, we used the positioning of the emulator screenshot of all the elements, and we tried to translate that to the actual Nintendo screenshot. And it didn't quite work out. So let's open this up here. If you notice, I'm recording a bit differently today. It's so hot upstairs, I've taken down my green screen, and we're just going to have to make do with this because I'm not working on the second floor today. It's too hot. All right. So, we were looking at trying to see if I can get this. Yeah, we were taking this screenshot. We're trying to read the information from it. And hold on, I have to... One second, folks. Okay, we're good. Okay. Let's see if we can't see this. I think it was called testing. That's right. So this is, we tried to get the score, and we sort of successfully grabbed this portion of the screen to get the score, but you can see it's a little bit vertically out of alignment, and I thought that was an issue because of the different sizes and images between the emulator screenshot and the real screenshot. But I discovered something that sort of destroyed all that. Let's go back into Visual Studio. So the key here here's the Nintendo screenshot. And here's the emulator screenshot. It's much bigger, but there is a difference. And if you'll notice, the emulator screenshot has less picture on the top compared to the Nintendo screenshot. So in the Nintendo screenshot, you have these Tetris pieces. There's a long bar right there in the middle, but you also have a row above it. A little bit, not the entire row, but it's there. But on the emulator screenshot, it's not there. It's not there at all. So the emulator screenshot is actually different, and everything is shifted down or shifted up. So all of our pixel values where we expect the score to be is going to be different even after we make the calculation to bring it into the Nintendo screenshot world. And so this made something very apparent to me. I was assuming we could use the emulator screenshot as sort of a guide and translate it to the Nintendo screenshot. But because the emulator is actually throwing out some of the image, I think I have to do the other way around. I think I have to treat the Nintendo screenshot as canonical, and we might not be able to read information from an emulator, but that's kind of not what we wanted anyway. So, before I do any more talking, I realized, how much room do I have? I have 967 megs free. I realized I need to download GIMP, so 1 second, bear with me here. Hopefully this doesn't take very long. Nope. Okay, so while that's downloading, we are going to switch gears and treat the Nintendo screenshot as our canonical screenshot. Let's have a look at what we did. So we get our screenshot, we send it into Data Extractor, we reduce the image, right? So reducing the image takes away all the black pixels from the edge, but I realized something else. If you look at this screenshot and we zoom in, actually that's not bad at all. Reducing it is going to actually that's okay. I thought maybe it was curved more at the top, where we might have to actually shave off part of it when it wasn't all black. Oops. And at the end here, I think we're actually okay. That's going to be okay. Okay. Excellent. So we reduce the image. We look at the score, and the score, all these numbers, 1411, 1080, 1054, 269, these are all based on the emulator screenshot, and it's going to be totally wrong now. So we're going to have to recalculate all that, unfortunately. Okay, this is complete. Let's install GIMP. Hopefully I have enough room on my hard drive for this. If not, we'll just make more. The other thing about the screenshot, though, not that. This image. We got this image based on our calculations where we thought the score should be based on the emulator screenshot. And horizontally, I think we did a pretty good job. Vertically, I think the emulator threw out only vertical real estate, and it didn't throw out horizontal real estate. That's okay. The other thing I'm noticing is we zoom in, it's very multicolored. And like some of these pixels are so dark, but they're not technically black. And so they're going to be treated as non-black pixels in our algorithm. We may have to turn these images into black and white before we start. But we'll cross that bridge when we get there, if we have to. An error occurred. There is not enough space on the disk. All right, bear with me 1 second, folks. I don't have enough room on my hard drive. These are the adventures that you get to join me on. So when you run out of hard drive space, and now it's installing updates. Thanks, Windows. Well, now what? Now I just sit and talk. Happy Canada Day. I miss baseball. Tired of coronavirus. Sucks. That's about it. Still installing an update. Well, that stinks. How could it install an update when I don't have any room on my hard drive? Still installing an update. Okay, well, while that's happening, we're just in a virtual machine, so we can just minimize that. Let's go on the internet and get some more screenshots of Nintendo Tetris, classic Tetris being played. And let's see if everyone's capture card actually includes those extra pixels that mine so obviously does. NES Tetris. Let's do some image searches. Okay. We're going to skip obvious emulators. That's clipped. This is an obvious emulator. And look, it's lost those pixels at the top too. Okay, here is a screenshot from Harry Hong. And he's actually got does he have more? Can I say that he has more on top than me? I don't. It kind of looks like maybe a bit, eh? Oh, this is going to YouTube. Here's someone else playing. Well, see, that looks like an emulator, but it's got the extra pixels up top. It's got both lines. Interesting. So, okay. I think what I'll do is I'll customize it to my capture card, and then maybe we can make a little utility that can customize it for any other setup. But we'll make it for me because I'm the only one using this. Hey, how's my updates coming? Did it? Oh, it's powered off now. Okay. So I have to give myself some more space here. I have 33 gigs. Well, let's move me up to 40 gigs. Okay. That was a whole lot of nothing. Oh, I lost my resolution again. Oh, yeah. Okay. And I have to grow my partition. Oh, this is super fun stuff. There we go. Now, do I have to restart? $6.5 gigs. Works for me. Okay. Now let's try installing GIMP again. One more time. Let's get our project open here. So my goal now is to find the actual screen coordinates of my real Nintendo screenshot. And once we've got that, then we'll find the coordinates of everything else, and then we should be good. So actually, maybe we should make a model for all this data. And then if we need to customize the positions that we look at, we could just change the model and maybe supplying a model via some settings configurations. That would work. I think that's a good idea. Look at this. 17.5 minutes in and we haven't done anything. That's fun. Okay. Awesome. We're almost there. So yeah, let's get some model here. Let's create a model. So rather than the Tetris data model, this is the extraction model. The Tetris extraction model. Okay, so there are key pieces of information that we are going to need. So we are going to need to know the width and the height of the actual gray part. Okay, so I think we're going to do that. Height. Okay, that's after it's reduced. And then we're going to need the score. The score XYs. Public point score. Okay, and a point is just an XY coordinate, so that makes sense. Public point lines. We'll do one for the level as well. Now we don't, whoops. How did this install? It's still going. We don't need one for the, like all of these piece count x coordinates will be the same. But that doesn't matter. We'll just set them as points. So what do we got? We got 7 of them. And what are they? Let's go to my Tetris data model. Copy them all. Whoops. T. I'm going to replace all numbers with T point. Yeah, point, sure. Okay, and these integers will all be points as well. So this is a model that will help us determine where we look in the reduced image for all these pieces of information. Okay, that's fine. All right, and so then in the data extractor, when we get all data, first we'll reduce image. Then we'll get the extraction model from the image. Okay. Okay, that's fine. Okay. The thing we need to know is the character width. So we'll say const character width. Oh no, I can't make it a const. The character width equals our bitmap width divided by 32. I think because we determined last time there was 32 characters across, and the height is, how many were there? I can't remember. Where did we see this? I think somewhere we had this. Is it here somewhere? Yeah, 1 second. I calculated it out, wrote it in the notebook, and then brought that notebook to work. So I don't have it here. We'll have to do it again. Oh gosh. think it was like 24. I want to say 24. Well, let's try 1080 divided by 39. 27.69. Yeah. Okay, let's open up GIMP then, and we'll let GIMP figure it out for us. Each character is going to take the same amount of screen real estate. So let's open this up. And I want to take maybe all of these, copy, paste. No. Duh, what just happened? Oh, I copied the whole thing. Ah! I don't know what I'm doing. Okay. Here we go. I'm going to copy these. Copy, paste. Good, now I have more of them. I'll go like that. Then I'll paste. And go like this. Okay, now we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29. 29 down. So 32 by 29. And we'll see if we're right. Okay. All right. So let's do this. The score has to be 6 characters wide. We'll delete all of our changes there. And we will do this. So I'm going to roughly draw it out. Now the size of this is 130. 130 divided by 6. Oh, wait a second. I don't actually know the width. Haha, oops. I think we'll just go 21. Kind of looks like 21 to me. So let's just say they're 21 pixels wide. We could change that later. Okay. 130 wide. And no. What would 22 times 6 be? 132. Does that look right? I think that kind of looks right. And then by 21. Okay, so here we have it. GIMP has told me that our position is 525, 146. Uh, 525. Come on. 146. Okay. Our level is equal to the level. Let's do the level. It's down here. And 21. So let's make it 42 by 21. That looks good. We'll drop the position up one. There we go. That looks right. So 571, 400. Okay, let's get the lines. The lines are here. Okay, 21 and 66. Looks pretty good. If I did 63. '63 looks pretty good. So 423, 48. Okay. Now the T count that doesn't look so okay. That looks better. These look bigger. See, that's tough because it's just 1 second, folks. I'm going to make a big clap. All right. Sorry about that. So we're going to have some issues here because the dividing line is going to be right here. Hopefully our algorithm will solve the issue. Be able to take care of the issue anyway. That's all we want. Okay, so let's get back out of here. This looks okay. We're going to use the 148 position for all of them. So I'm going to write that down, 148. So the T piece will be 224 on the Y. So the T point equals 224. So 148, 224. Okay, we're gonna, can I just bring this down? Ha, I can. I'm just worried about the Y values now. So then we'll say 263 for the J. 263. .302. That's the Z. This is fun stuff. 341 for the O. I'm laughing because we have someone outside coming to pick something up and they refuse to walk up to our door and ring the doorbell. They insist on messaging us. Like, people learn to use a doorknob. Or just knock. 380. This is the S. Like, when did our society decide to, like, the contract when you go into someone's house is to ring the doorbell or actually walk into their yard? When did that change to messaging on the phone? 419 for the L. The long bar, oh boy, this is odd. It's like, ugh. Okay, well, whatever. That's okay. 458. So I'm not sure if that's going to work, but I'm not sure why I want this either. The height and the width, but that's okay. Okay, let's get back to reality here. Yeah, what am I doing? I'm doing something. I've got my points. Let's deal with the score now. Instead of all this scaling nonsense, we're now going to look at the score. So return screen reader, get value. Come on, at. This is our bitmap. Oh, I need to bring in my Tetris data extraction model. Extraction dot score. Come on. Dot x extraction.score, can't spell score, .y, and the number of digits is 6. This is going to be a very interesting video. I'm trying to do Tetris here. Oh my word. Okay. See, the number of digits now, I shouldn't actually... You know what, I should do a width. In widths here. Just a width, because the height will always be the same. But now I don't want my number of digits to be calculated in this method. Alright, this is silly. Oh my word. Well, this will be awkward. Oh. Well, okay, we're back. The pickup saga continues, but I'm going to try and do this. So, our get value at, no, I can't do this. I can't do this. Anyway, am I going to edit this out? I don't know. Maybe I should. Well, okay. Okay, so here we are again. And our hour is almost up. We haven't done anything, but we've had a great, tremendous time at chronicling this craziness. But okay, so our width is coming in at value at instead of our characters. So, because we're going to have that in that calculation is not going to be in our screen reader. So we're going to have our X, Y, and our width. The size is going to be... Oh, no, I need our height as well. Int height. Because I need to know the height of a character. I still want to be able to resize the image. So let's get our height in our interface here. Int height. Oh shoot, no, this isn't going to work. The width and the height, and I need to know how wide a character is. So, num digits. Because I don't know how wide a digit is. So, okay. We'll have to say how many digits we want as well. Okay, so num digits. So then we're going to say car height equals height. We don't need that, but we do need car width is equal to the width divided by the num digits. Okay, so column times car width, car height. We'll just call this car height. Okay, this is car height. And then we'll get the digit image, and the X scale used to be I think I just want car width and car height for the scale. I don't need the scale. Oh boy, now we're changing everything. Because I don't want the scale anymore. I don't know what I'm... so we'll say int okay, we'll change these to char width and char height. We're going to pass these into our method where we get the probability list. These are now, whoops, char width and char height. Okay, this will be char width, and this will be char height. Char height. Get probability for, you know what? There's the canonical image. I wonder, shoot, we're not gonna get very far today. This is gonna be a dumb day. A dumb day where we don't get anything done. Because I need this to be width and char height. But now we're getting the canonical image. And now we're scaling. We can't scale it. We cannot scale the canonical image. Shoot. But we do have the reduced image here. Actually, if we have the reduced image, I want the original image not reduced. That's char width and char height. I want to get these canonical images, but these are reduced. And I actually don't want to reduce them here. I want these to be real. I want these to be absolutely real. I think I might have to take our test images and bring them back. But I don't know. This is hard to know. what we might have to do is take new screenshots. I don't think I want to, but I think these reduced images aren't good anymore. So I'm going to delete them all. Cannot remove the disk. Why not? Well, maybe because that had something in it. Okay, I'll save everything and I'll close Visual Studio. Oh, because that's probably over there. Okay, we'll go back. I want to delete that. We're just over an hour. Our time is almost done. I'm just going to bring in the canonical images from the tests. We'll put them in there. I don't think we're even going to be able to run anything today. But at least we'll be set up for next time where I'll be in a better headspace to solve issues when they come up. So let's get these test images, which we're very familiar with. I want to delete this. Can I delete this now? Yes. Okay. Now we will add a new folder called canonical images. And we'll paste these things here. For each one of them, we're going to make sure that they are content. Okay, so they'll be in all of our tests. So now what we need to do is when we actually get the canonical image, and actually we're yeah, if no, let's not even do that. We're just going to assume we'll have to resize it every time because we will. I want my canonical image to be a nice crisp image. So we actually have the width already. We don't need to do any of this. So the canonical image, this is the size or height. So we've resized the canonical image. Why does this? Oh, because it's integer. But it's not reduced. And so we're going to reduce it. Reduced canonical image equals image. Did I call it a reducer? Reduce image. Canonical image. There we go. So now we've resized the canonical image. We've reduced the canonical image. And now we're going to send this reduced canonical image. That should be okay. Now what is this complaining? Bitmap decimal decimal. Oh yes. Because it's not decimals anymore. Okay, that's done. I kind of think we're going to have some more issues. Let's build it. See. It would be nice to see the score work before we close this off for the day. Rebuild failed. Well, that stinks. What's the problem? I forgot a semicolon. Width. That's the X. That's the Y. I need a width and a height and a number of digits. So the width is going to be extraction dot. Actually, we're going to actually put in some, let's call it digit. Digit height equals the bitmap width, no, height divided by 29. That'll be an integer, and we will math.round that. Digit width is going to be this. Okay, this is being complained about. We need to add that. Generate property. Generate property. Okay, so now our model as the digit heights and widths. So now we're going to say extraction digit width, extraction.digit height. It's 6. Width, height, and num digits. Okay. All of these things are going to be wrong. Oh. Crap. Gosh darn it. Okay, return 0. I think I'm just gonna... Actually, we're not even referencing this right now currently. What I'll do is I'll just do this. We're only dealing with the score. We'll comment all that out. Oh, this is fun. Everything's commented out. What's the issue here? What's the problem? The name lines does not count. Oh, for crying out loud. Just return 0. There's no argument. Oh. Extraction model. Okay. Is that okay? Can I build everything and trying this? Nope. What's this is the tests. Nuts. Okay. I'll comment this out. And we'll just comment this out. I could comment things out. Now, are we ready to do this? Okay. Well, this is kind of a success here would be nice, but it's not going to mean a whole lot. It'll mean a little bit, but not a whole lot at this point. But let's run this. Okay. We're going to load it up. Go into the data extractor. Out of there. Yeah, no, that's fine. We'll go over. Get all data image. So we reduce the image, and it's interesting. I wonder what the new width after reducing is. The new width is 677 by 574. I'm going to write that down. 677 and 574. Okay. We've got our extraction model. Oh, so the digit height is 20 and the digit width is 21. That might not work. See, now the width is 3. Oh, but I don't use it. I use that crop area sub-image. Okay, I wanna save this sub-image. Sub-image dot save testing2 dot emp. Let's go into we're now going to take a look at what the image that the score is. After all of that, oh, GMP. So this was the one that we created last time, and we couldn't figure that out because we're a little off center. Let's make this a BMP. Yes. So this is what we're after now. Okay, this is the 2. So that's it's not bad. Not great. Why is my crop area my width? Why is my width 21? My height is 20. Wait a second, that's not right. Huh? This needs to be digit width times 6, that's why. So maybe get value at width times num digits. That's better. But now, when I do this, okay, maybe that's okay. Get value at. Okay, I'm going to put a breakpoint here. I'm going to run our test one more time. So I have a sub image that's 126 pixels wide. Interesting. We started at the 2. Why did we start at the 2? Did I mess up my score? Oh, shoot. Because I reduced the image. That's why. Now these are based on non-reduced images. Okay, whatever. This is obviously not going to work, but I want to see it recognize each digit. So this is what we're trying to recognize. It should be 29,29263, and then the test should fail. So what is the digit that it thinks it is? Oh my word, parameter not valid. Ah! Get file name. Yeah, because it won't find that file. Almost done. I need this, just need this to show me something. I gotta remember all these issues. This is a suffer experience. Okay. Parameter is not valid. Oh my goodness. My head's already done. My head is done. Okay, let's try again. Oh my goodness, it recognized the 2. Dudes, it recognized the 9. What is going on? What is the final number? 292633. 29263, and because we shifted over, that's not an actual number, but it matched up with the 3. This is actually a win at the end. That was a long haul. Okay, I'm going to stop it there because I got other things to do. Thanks for joining me. Have a nice day, and we'll see you next time.